Hello, everybody. It's Mrs. Pound, and we are studying weather in Chapter 5.2. So today's topic that we're going to talk about is air pressure in Section 522. The objectives for today's video are to describe the factors that affect air pressure, compare low pressure and high pressure areas, and demonstrate how atmospheric pressure relates to weather, and explain how a barometer measures atmospheric pressure. So atmospheric pressure, the reason we are studying it is because it really is what drives our weather. And so we're going to be talking about this throughout the entire chapter. Now, changes in atmospheric pressure are caused by rotation of the Earth, gravity, solar energy, and altitude. So let me just talk about a few of these for now. As far as rotation of the Earth is concerned, it actually causes different areas of pressure to move across the face of the earth. So that's what uh, that affects. Gravity pulls air towards the earth, and so that causes differences in pressure. So pressure, atmospheric pressure is greater the closer you get to the earth. It is not as great the farther you get away from the earth because of the gravitational pull on the molecules in the air. Solar energy affects pressure because solar energy heats the air. Heated air rises and lowers the pressure, and then as the air cools, it falls, and that produces convection currents in our atmosphere. And also altitude. The higher you are up, the lower the atmospheric pressure because there are fewer molecules being pulled by gravity down on top of you. And so you probably have experienced this. Maybe if you go up in a mountain or even a really big hill, or if you're going up in an airplane, your ears will pop. Maybe you'll get a headache, your ears will hurt. This is because it takes time for air in different cavities of your body, like in your ears, to equilibrate, to change the pressure. And as long as that pressure is different, you will feel some discomfort and maybe even some pain. So let's first talk about a low pressure area and its characteristics. Now, above low pressure here on weather maps, low pressure is a capital L with a circle around it. So I want you to draw a capital L with a circle around above low pressure here. That's how I'll know you're listening. It's characterized by warm air rising because you can imagine if warm air is rising, the pressure is lowering. Okay, there's less pressure from the air because it is rising, and that's what causes a hot air balloon to rise. Is it the warm air um, causes it to rise? Strong winds develop because this is there's a difference actually between low and high pressure, and you're having strong winds develop in a low pressure area because air from high pressure areas is pushing in and causing the wind to blow. Also, water vapor from warm air condenses to form clouds. Warm air can hold more water vapor. When it rises and cools, that water vapor condenses and forms clouds, so it gets cloudy. And so low pressure areas tend to be characterized by cloudy skies, storms, rain showers, and blizzards. So if you hear on the weather that there is low pressure over us, count on a storm. A high pressure area is characterized by, now, high pressure on a weather map is an H with a circle around it. So go ahead and above high pressure in your notes, write a capital H with a circle around it to show that you're listening. This is due to cold air sinking. So if air is sinking, it's pressing harder down on you. So that's what causes the high pressure. And it's these convection currents going on. It prevents the formation of clouds. It kind of pushes all that the clouds out of the way. And it's characterized by clear, sunny skies. So if you hear that there is high pressure over us, you can count on a nice sunny day. Does that mean it's necessarily going to be warm? No, but there are not going to be any clouds. Now, how we measure barometric pressure with a barometer. This is an instrument used to measure atmospheric pressure. And the first barometer was actually a column of mercury. That's why, if you look closely at this barometer, it says CMHG, if you can see it on your screen. That's centimeters of mercury. It measured how high the air pressure pushed a column of mercury. And you'll see centimeters of mercury, millimeters of mercury, you'll see inches of mercury. Um, and in class, we have made barometers using water, and we're watching to see if the barometric pressure will move that water column in our tube up and down. And it's the same idea, except for originally mercury was used. Now, the mercury in a barometer rises when the air pressure increases because the air's pushing down on that column, it's pushing it up the tube, okay? The mercury in a barometer falls when the air pressure decreases. So the air pressure lets up, the column falls down. And so that's why we say that the barometric pressure is rising and falling because we're comparing it to what's happening in a tube of mercury. Now, in the background, this barometer does not contain mercury. Okay. This barometer has like a diaphragm in it that will expand and contract. And if the air pressure pushes on it, the dial goes up. And if the air pressure lets up on it, the dial goes down. And so it's able to measure the pressure that way by how hard the push is on the casing around it. So, our objectives today were to describe the factors that affect air pressure, compare low pressure and high pressure areas, demonstrate how atmospheric pressure relates to weather, and explain how a barometer measures atmospheric pressure. So, don't forget your 5 questions, and I will be back with a lot more about weather.